Hey robot makers, hope you're having a good day so far. So let me get my notes open over here. So if you want to learn about the best robot for beginners, the best Arduino robot for beginners, then this is the show for you. So let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to my notes that I've made for this particular show. So yes, this is all about the best robot that you can build using an Arduino. And the reason we're doing this today is it's the 20th anniversary, 20th birthday of Arduino, the company, and also a little board that they created that made all this happen. Did just drop that. So today's goals, we're going to have a look at 10 reasons why I think this is the best robot for beginners. We're going to have a look at some SMARS resources as well. I've created quite a few of those myself. And then of course we're going to have a bit of a demo. We're going to remotely control using the gamepad remote. We're going to control the SMARS robot. And one of the reasons I find this quite an interesting project is that the remote control is running MicroPython on a Raspberry Pi Pico. And the SMARS robot is an Arduino based robot that's coded in C. So we can use different languages to complete a task such as building a remote control robot. Really love this. I've also got quite a few things to show you in the live stream after show mailbox. I've got lots of things to show you on that. So let's get to it, shall we? So what is a SMARS robot? I've got one just here. I've got quite a few just here, in fact. So these are a screwless modular assemblable robotic system. So this is one of the novel things about this particular robot is it doesn't require any kind of screws or glue to assemble. You can assemble the entire robot, 3D print it, add the electronics, and everything sort of snaps together. Some things like the little ultrasonic rangefinder, that just slots into place in some little slot at the front there, but gravity keeps it in place. And there's some really nice features that we'll get into, such as these tracks and how they work. So this is one of my favourite robots. This is the first Arduino robot that I built, the 3D printed robot. I think my very first robot. I'll show you on the website after the main show if you want to see that one. So what is SMARS made up of? So it's a 3D printed robot, so you'll need to have a 3D printer or access to a 3D printer. You can get things sent off to be 3D printed and returned to you. Companies like PCBWay will do things like that for you if you're interested in getting one of these built and you don't have a 3D printer. So these are Arduino Uno based robots. So if I just grab this here, I've got an Arduino clone. I've got quite a few genuine Arduino products as well, so I don't feel too bad. But this is open source hardware. So there you go, we have an Uno. So this is the 8-bit microcontroller, the newer version of the Arduino. Grab this floor here. Let's put it back in its little carry case. So this is the 32-bit version. This runs on an ESP32, but it's still classed as an Arduino. This is the Arduino R4, revision 4, and this one has the Wi-Fi module. So the little chip there has wireless and Bluetooth capabilities. We'll be using the Bluetooth capabilities today to make this into a remote control robot. And it's also, this one also happens to have a little display. It's got an LED matrix where you can actually display messages and things like that. We're going to be programming this in C++, the Arduino language. We'll be doing that in the demo very shortly. So this robot also requires a 9-volt battery and a little 9-volt battery connector. So these little, what are they called? PP? It's not called PPA, is it? I don't know what they call these. 9-volt battery. You can get rechargeable versions of this, so if you find yourselves going through a lot of these batteries, which isn't great for the environment, you can get rechargeable versions. I've got quite a few, and they just have a little USB connector on the side, and they have like, say, 400 milliamp hours, which is more than enough for this little robot. This robot uses these N20 motors. I'll just show you one of those. So these N20 little micro metal geared robot motors. These are fantastic. They have a little spindle which has a D kind of shape. It's like a circle with a little cut off, and we can attach these little 3D printed wheels to these as well. So we just find the where the little notch is, and they kind of push into place, and that means that we can have a little wheel that we've 3D printed. And these wheels have got a very specific design. We'll get into that a little bit later on. So that's the N20 motors, and then to make the whole thing go, we need a shield. So Arduino's call the add-ons that go onto the top of the board that plug into the little GPIO pins, shields. So this is a little motor shield. This is one of my favourite ones. It's very low cost, but it can do an awful lot. So this one is called a Fundimoto motor shield for the Arduino. And this will work either with the R3 Arduino or the R4. So right in the middle there, that's the motor driver chip. This one also has a buzzer, which is that little round thing there. It's got other connectors as well, such as the power connector. You can connect your 9-volt battery in there. And then there's two sets there for motor A and motor B, which is our left and right motor. This also has some other connectors on there for things like servos. So if you're building a SMARS, such as this one here, which has a forklift truck connector on it there, so this is like an add-on module. So it simply has a servo there, and there's another motor that can drive this up and down. That can connect up to the little servo headers that are built onto that board. And of course the thing that gives it its personality, its little face, is these ultrasonic sensors. So this is an ultrasonic rangefinder, the HC-SR04. But with this being an Arduino based one, we can go for the very cheap ones of these that are 5-volt tolerant. There is another version which works better with lower powered microcontrollers that are 3.3 volts. In fact, this one is one of the ones that work with the 3.3 volts, and you can usually tell because on the side there, at the very back, it says Echo Transmit SDA Trigger RX SCL, and it can do I2C or serial UART. So it's got the usual kind of 4 pins on there. So either of those will work, the 5-volt or the 3.3 on the Arduino, because it's 5-volt tolerant. So, Arduino powered. So you can see there at the top, that's the original Uno R3. That's the board that started me off in robotics. So I started out with the flashing LED and kind of moved on from that to like, what else can we do with this? And I found that I wanted to have a 3D printed robot. That's where I came across the SMARS robot, which was created by an engineering student at the time called Kevin Thomas. So the Arduino Uno, this is the board that started them all. This is the board that kick-started all those microcontroller boards that we see now 20 years ago. So it's this, the R4, which is on the bottom right there. This is the latest incarnation of the Arduino. This is the kind of Maxima version, if you like. There's a Minima version, and then there's this Wi-Fi version that has all the Wi-Fi and Bluetooth stuff. The Minima version doesn't have any of the LEDs on there or the Wi-Fi capabilities. It's just a kind of bare bones board. So this Arduino has a Wi-Fi and Bluetooth, and that makes it really easy for us to remotely control this robot right out the box without any extra connectors. We do need the shield for the motors, so we'll still be putting the shield on top of this particular robot. And there are lots of shields available for the Arduino Uno board, as well as the Arduino Nano family. 20 years worth, in fact. That's how long this has been going. So, reason number 1, I think this is the best robot for beginners. Best Arduino based robot is it's really simple to construct. So all you need to start out with is the chassis. This is one of the chassis. I've got quite a few variants of this here. This one's got the wheels attached. So there are 2 types of wheel on this robot. There's the powered wheel, which has the smaller connector for the motor to connect to, and then there's these free spinning wheels that just kind of connect on to those lugs that you can see on the chassis there. So these are kind of 3D printed in 2 parts. The little lug there has got this gap, so you can slightly squeeze them together when you put the 3D printed wheel onto it. So that's how we can connect up. If I get this one off here, so the motor simply goes into the chassis, clicks into place. There is a little motor holder piece which slots into some little slots in there, and then we just friction push that into place, and that will then hold that motor into where it needs to be. Just force that down there. You tend to give them a bit of a bend, and then they'll go into place. And they also hold the motor, the battery, into place as well, so the battery can sort of sit in between both of these. I'm trying to do this live on the show. It's a tiny bit fiddly to do. There we go. So the battery sits there. We put the other motor in the other side with the wires connected, and they can then connect into the shield. And we simply just push the wheel onto that spindle, and there we have the powered wheel, as you can hear. and we have the free spinning wheel. And then we connect some tracks up to that. Now the tracks are one of my favourite pieces. We'll have a look at this specifically on another slide in a second, but these tracks will essentially go round both the wheels. You tend to have one piece that you'll pull out to make it easier to connect. Let's just do that. So wrap that round there, and then there's a little pin that you can push into place to connect the whole thing together, like so. And then we have a little track, so the motor can turn one wheel and the tracks turn the free spinning wheel there. And we have one motor in one side, one motor on the other side. They're kind of at diagonals on the design here, but that doesn't matter. We can figure that out in code, how to make these tracks go backwards and forwards. The tracks give us a lot of traction, so this is why, from a construction point of view, this couldn't be simpler. So if we get our Arduino board, let me just find one that's got the Arduino in it. Literally had that a second ago. There we go. Let's use that Uno board that we got there. We simply just slide this into place. There's two little slots, and that slides into place like so. So we've got the actual Arduino within the robot chassis, and then we get that motor shield, and then we just push that into the GPIO pins on the top to kind of create a little sandwich there. This is quite an old one that I'm using here, so it's a little bit loose on the slots and things. But you get the idea. That's how we construct our little SMARS robot. Very, very simple to do. No screws, no glue required, just 3D printed parts. Everything sort of snap fits together. And that simple construction means you can spend more time on learning programming, using your robot, rather than messing about trying to get this thing to work. But the fact that you put it together with your own hands and you constructed it really gives you a sense of achievement that you've created this robot. And because you've created it yourself, you understand how to take it apart, how to rebuild it, and how to potentially modify it with your own add-ons. So number two, it's DIY robot. All the parts are 3D printable. That means we can customize them according to your needs. So there are different add-ons, different versions. This one has these TT style motors. There's a slightly different wheel that has the TT style connector on the end there, which is the that kind of shape. So it's slightly different. It's very, very easy for us to modify these. And in fact, I did an entire series on how to design each component one piece at a time as the very first videos I did on YouTube. So if you want to know how to design the chassis in Fusion 360, I've got a video on that. If you want to know how to design the wheels, I've got a video on that. If you want to know how to design the motor holders, there's a video on that. If you want to know how to make the rangefinder holder and the rangefinder cover, there's a video on that. So we've got you covered. Even the tracks, even some novel wheels as well. So you can customize all these different parts to fit your exact needs. So we're just talking before the show about using TPU, which is a flexible filament. You could print the tracks using TPU to give them more flexibility so they can stretch more, potentially even print them in one piece and then just put them over like an elastic band in effect. And that'll give you a lot more traction than these solid printable ones. You can see all the different components that we have there. So we've got the motor holders, the chassis, the battery, the tracks, the wheels, the motors, the rangefinder, which is that little, where's it disappeared to? Put these things down then and I can never find them again. That's our little rangefinder. And then there's a cover that goes over that. And there's also a little holder that it slots into. And that means that it can sort of be held in place on the front of the robot. So that little piece there just slots into place like so. And then we have our little rangefinder in place there. And then there's a 3D printed cover that goes over the top of that. So yes, you're getting to DIY robotics when you build a SMARS robot. Power control. So this is a trusted and tested Arduino microcontroller. And the Arduino microcontrollers are really robust. They can survive, accidental shortings out and things. They're quite tolerant of things like that. The 5-volt nature of the pins as well means that they're very tolerant of any TTL electronics, which is the through-the-hole type components, rather than the more delicate 3.3 microcontrollers like the Pico or the Arduino Nano or the ESP32. I think the Nano may even be 5-volt tolerant. Introduces beginners to programming in a really fun way, because there's nothing more tactile than having a robot move when you've written some code, or a robot smash into something because you've not told it how to stop. Things like that are really fun ways to get into programming and get people thinking about how their code actually works. And there is lots of examples and code to get you started. I've got some resources for you in a couple of slides time. So it's really durable and steady. This robot can basically go over anything. We've got this one here that's got these red tracks on it. So yes, really solid design means that it's got some longevity to it. It's a really robust design. The fact that everything slots together, snaps together, if things fall off, or well, not so much fall off as if you crash this into something and that rangefinder pops off the little thing that's holding it in place there, you can just put it back on. If this little face piece comes off, you can put it back on. It's very, very simple to sort of fix things and get up and running. So I like the durability of the design. And these tracks, they can crawl over anything. So you're going from like flat flooring to carpet, no problem at all. Really, really like the design of this. So the tracks, they've got this really unique design. So the tracks are actually individual pieces. Let me show you one of these pieces here. So there's some tracks I printed on my Prusa, and you can see that they all bend, but they've got a tiny little pivot in each piece. And that pivot, you can see it a bit easy on this this red one. It's actually just PLA filament cut to the right size. So I usually have one piece that's slightly longer than all the rest, so it's very easy for me to pull that out, so that we can move the tracks around and, you know, adjust the tracks and so on. So if I just move this track here, I try and pull out that filament. A bit fiddly to do again on a live stream. There we go. If I just grab that and pull that out, our tracks are now free, and we can now see how that works. So if I do this quite close to the camera, get it to focus in, you can see there's that little hole there. We put the filament into that little hole, and now we've got that bendable track, all 3D printed. That's the genius of this design. It would take an engineering student to come up with something like that, I think. So there's 16 segments per side, so if you want to create the two sides, you'll need 32 of these tiny little track pieces. And the design of them is quite neat as well. They've got like a smooth bit and then quite a sharp bit, and that means that they get really good grip on almost every surface. And these are just hard printed PLA. Again, we can just pin that together and we can create one piece of track. Okay, so again, that means we can focus on what we want to do with it rather than will it work. It will work. It's a really well trusted and tested design. Sensory exploration. So this is one of the things I think makes this a true robot. It's not just a remote control car. You can get feedback from this rangefinder. You can detect the distance of objects in front of you. You can avoid objects. So if it detects something within 5mm, you can say reverse back, turn 90 degrees and carry on. If you want to follow an object, you can say maintain a distance of 5cm to the object in front of you. So if it goes less than that, you go forward. If it goes more than that, you go backwards, and so on. So you can trace things, you can avoid things, create all kinds of interesting interactive feedback loops. And really that's the nature of robotics, interacting with our environment, reacting to it. These rangefinders are very cheap to buy as well. You can buy them, I think, for like less than $1. You buy them on, say, AliExpress. I bought quite a few of these. I've got a small stock of them in here, and they're really robust, between 5mm and 300mm range, so got quite a lot of play in the range there. And like I said, you can track or avoid obstacles with that. Love that feature. It looks cute as well, as like a little face. You can expand and extend the SMARS robot. So as you've seen there, we've got, grab that forklift version again. So this one is one of the first things I printed out. So this is a forklift truck. There's a little motor inside there that's got a really, I don't know if you can see, if I pull this off you can have a look. You can see there that there's a really long N20 spindle on that, and it's got a screw thread. So the motor sits inside here, and if we sort of turn that round, this would make this go up and down inside that little track there. And it has a servo on the back, so it can sort of tilt. So that's like a really fun way you can make an entire construction crew. Reminds me of the remember Fraggle Rock? They had the doozers, that's what they were called, and they made all kinds of constructions. Kind of reminds me of that a little bit. So I did just drop that a little bit there. Let me just put that back. Okay, get to that in a second. Some of the other notable things on here, we've got that little yellow bucket. Not sure I've got that to hand anymore. So you can make a little, I don't know what you call it, like a construction robot. We have the one that's got the line sensor. So in here is a little infrared line sensor. There's essentially two little things in here. One shines out infrared light through an LED, and then there's also a little sensor. So that can detect lines and follow lines. Very simple to make that work. You just draw a black line on a surface on a sheet of paper, and it'll follow that round. What else have we got there? We've got a microbit version at the top right there, you can see, and then there's also the version with a little face as well. So I was just showing that at the very beginning of the stream. If I can find my battery, where have I put my battery? We can get that up and running. I think I'll just move that off somewhere. Never mind. So yes, this one has a little 8x8 matrix, and we can use that to display like a face or text, scrolling text, whatever we want to. So that's another add-on, quite a fun one. I'm really not quite sure where the battery disappeared to then. Never mind. So you can design your own parts as well. If you want to get into 3D design, this is a really great way to get started in it. And there's a whole wealth of resources for SMARS robots. So it's a really mature robot platform. It's been around a number of years now. And I was so obsessed with this, I created smarsfan.com. So that's still running. It's one of the earlier websites, predates kevsrobots.com, which is more about general robotics. This one is specific about SMARS robots. And it even has an early version of the learning system that I put together, the learning platform. You can also go to Printables or Thingiverse to download the original SMARS robot. And there are other versions of SMARS. There is a 4-legged quad version that can walk around. Last week's show featured the Raspberry Pi Zero version of that. And there's of course the Kev Robots community over on Discord. We have lots of resource available for people on SMARS as well. But smarsfan.com is the place you want to go to if you want to learn how to design and build. All the videos are sort of curated on there for you as well. So a wealth of resources for you to get started. So if you like what I do and you want me to make more of these kinds of videos, give this video a like. Let me know that you like this video. We've got 16 likes so far and 1 dislike. Who's giving those dislikes? And drop me a comment. Let me know what the robot is that you're currently working on. The Arduino robot that we have just here is the Alvic robot. This one is powered by the Arduino Nano ESP32. And if you haven't subscribed to the channel, please subscribe. It means the absolute world to me when people subscribe. So drop me a subscribe. Costs you absolutely nothing to do that. And I do go live every single Sunday at 7 o'clock GMT. We'll be getting into British summertime very soon, no doubt. Absolutely no doubt. So that'll change when we get into that period of time. But yes, live every single Sunday. So join me if you can there. So SMARS is an open source robot. It's fully open source design, which means you can share, modify, improve it. And you've got the community support behind you to do that as well. I've even developed some free courses with all the dimensions and design instructions on how to build each part. And if you know how to design each part, you can also then modify it to suit your exact needs. If you've got a 3D printer, you can even send that to your 3D printer and have your own robot printed out. So open source means that we can do all those amazing things, and it's such a gift that we're able to do that as well. Number 9 is it's an affordable robot. So robots are quite expensive. If I grab this Alvic robot, I bought this one from Arduino when this one very first launched, and for what it is, it's quite expensive. If you're a school or a college, unless you can get some kind of additional reduction, some discount, these can be quite expensive, and particularly if you're buying them in bulk. If you have access to a 3D printer, the majority of the cost is going to be just the actual Arduino itself, and you can buy the Arduino clones like I've got just here in this robot. You can buy these on like the likes of AliExpress, Amazon and so on for considerably less than the official Arduino robot. But if you are a hobbyist, I would recommend you buy the genuine Arduinos from arduino.cc, because you're actually helping support the work that they do to create the free code, the libraries, the support and the development of future boards like this R4. So if you can afford it, definitely do help out with that. It uses commonly available components, so the 9-volt battery, which is now disappeared. I'm just going to have a quick look to see where I put this, because it would be cool if I could demonstrate that other robot working. I literally had it a second ago as we were looking at something over there. But no, I cannot see it unless I dropped it somewhere. Nope, I think that one's gone. I've absolutely no idea where that's disappeared to. The full bill of materials for the robot is available on kedsrobots.com/blog/smars. If you want to know how much you're going to pay for one of those, you can head over and see the cost there. The price of the motors, I think they're about between like $5 and $10 each. They're probably one of the more expensive parts of the robot, but you can get them cheaper depending on the time of year and the supplier of those. They come in different RPMs, different speeds. I think I used the 150 RPM in a lot of my robots, so that seems to be a good mix between torque, between sort of pulling power and also speed. Number 10, hassle-free troubleshooting. So I've actually done a number of videos on how to troubleshoot common issues with SMARS robots. So you can see there's the top 5 common issues that you're going to get with a SMARS robot. So for example, one of the top 5 issues is that the tracks can be quite taut. So if I hold up this one here in red, if you look at the top there, you might see that wheel is slightly pulling inwards. That one is fixed, but the other one is sort of pulling inwards, and that's because the tracks are a little bit too tight. So you can actually fix that by printing one of the tracks with a Y. You can basically just change the Y-axis when you're printing this out and stretch it ever so slightly, say 5 to 10%, and that usually fixes up the issue, no problem. So yes, head over to my YouTube channel, search for the top 5 SMARS issues and how to troubleshoot them, and you'll be up and running, no trouble at all. Okay, and you can build your own SMARS robots. I've got a free course available on kedsrobots.com/learn/SMARS, and there's a whole learning path there about how to build each of the different types of SMARS robots, so you can get up and running today and delve into the world of robotics. Cool. So what we're going to be looking at today is using the gamepad, which is a gamepad I created, which if I just press these buttons here, this is actually remotely controlling a SMARS robot that we have on the desk that we're going to look at in a minute. You can buy one of these on the kedsrobots.com website. There's a link on the website for these gamepads, and they are very, very affordable, less than $10 to buy one of those. They actually run with a Raspberry Pi Pico, and that means that they're running MicroPython, interestingly. And the SMARS robot, we can program that in C++ using the Arduino IDE to connect to that and listen for button presses, button down and button up presses. So as we hold the button down, it can roll forwards or turn left or right. As soon as we release that, it can stop all the motion and wait for the next key press. So it makes it really, really interactive and really fun to do. So this is a fun project to extend your SMARS robot and make it into like a little remote control robot. So that's what we're going to be looking at today. So let's do that right away. So what I'm going to do first of all, I'm just going to get my notes up on screen here. So yes, the main thing I wanted to sort of draw people's attention to first was the difference between these two microcontrollers. So these are both Arduinos. These are both Arduino Unos. So the one that's in my hand here, this is an Arduino Uno revision 3 clone, and the chip that's on there, that is an 8-bit chip, which means it can only run a certain number of instructions, and that has like a really, really limited amount of memory. The newer version, which is the R4, this is the original or authentic Arduino R4. This one has a 32-bit chip on there, so that that chip that we can see there. And it also has a Wi-Fi chip, which is just there, which means we've got Wi-Fi and Bluetooth capability, as well as this lovely screen that's on there as well. Also has some more newer things, such as it has the USB-C connector there for connecting to things, as well as just generally a much faster chip. It's also got a little connector there for I2C add-ons. Where have we got those? So if you have the plug and make kit, which I've got just here, this has got all kinds of extra add-ons and things that you can connect up using these little cables, and that will connect to this little white connector that was just down here. So we can make our robot even more fully featured by adding some of these extra boards. So that's the first thing I wanted to point out. We wanted to look at the tracks. Now, interesting, the little robot I've got on my desk here, one of the tracks has just fallen off because I've not glued these on. I've just literally, so you can just see there, when it fell over, I just need to plop that on there and have these tracks just in place. So given that has come off there, we can probably do this a little bit easier just by doing this and then finding where that little hole is on there and just aligning with the D of the spindle on the motor. When it finds it, it'll just fall into place. There we go. So these seem to be quite well, they're not too tight. You can see that they're quite horizontal, the tracks, and the tracks really make this robot really robust. If I just give them a spin there, you can see that's how it would roll forwards, that's it rolling backwards, turning left, you can see the motors kind of going opposite directions, and that's turning right. So that's how our robot's going to sort of move around. You can see it's got the little rangefinder at the front there, so we can use that to detect distance. It's got that connected to a couple of the GPIO pins there from the little rangefinder, and we've also got the all the wiring there. So this little wire that's coming out the side there, that's the 9-volt battery, so that's going to provide 9 volts of power into there. This can then drop that down to the 5 volts that the Arduino needs to move around, and it means that it's got plenty of power for those motors as well. And then we've got two sets of wires here for the left and for the right motors. So that's how this robot is going to work. So I'm going to put this on the desk. I'm going to show you the code first. We're going to have a play around with it, and then we'll actually disconnect the cable and show you that it's truly remote controlled. Let's see if there's anything else I wanted to cover off there. Just that there's lots of different varieties. You don't have to use an Arduino if you don't want. You can use a Raspberry Pi Pico. So these boards by Kitronix are really great for just putting your Raspberry Pi Pico in there, and then you've got the same kinds of connectors. That one's got 4 motors, and it's got the connector there for the battery. So you could use like the 9-volt battery in there as well, I guess. And then you can use MicroPython and a Pico. We have these boards. These are from is it DR Robotics, I think. So this is another version. This one uses an Arduino ESP32, a Nano. You could use a Nano Every in there, or just a regular Nano. I think you can just about see there. This is from, does it say the company on there? I don't think so. And there's the back of the board. Yep, so there's no text on there about who provided that. So yes, lots of different options there. And then when it comes to the actual shields, so I'm just going to grab this shield. Oh, they're the ones on the floor there. So this one is by Deek Robot, and this is the motor shield. So you can see that's the motor shield driver there. It's got a series of different header pins there for, I'm not sure what they are. They might be for the servos, and then you've got the chock block on the side there for motor A, motor B, and then the power in at the very bottom there. That big capacitor there, that's the thing that's helping protect all the electronics from the rest of the power spikes that you potentially can get with motors. And I grab this one. So this is my favourite board. This is the Fundimoto. You can see it's got all kinds of things there. It's got like a Bluetooth header, it's got servos, it's got the little buzzer. There's even like a little connector for the rangefinder, and it's got the motor A and motor B as well as the power input. Also has a nice little reset button there, so you can reset it from the top of the board there. So these are very, very cheap, very, very affordable. I've got a very large stock of these because originally I was thinking about putting some kits together for SMARS, but then I never got around to it. So I've still got the stock of them there. Right, so what we're going to do next is just get this this robot on the overhead. So this is the robot that we're going to be controlling today. I've got all kinds of things falling off the desk there. So what I want to do though is show you the code about how this actually works. So I'm going to load up the Arduino IDE. I'm going to head over to the IDE here, which has got everything connected up. So I've plugged in the robot. I've got the code here, and if we just move things around a little bit so we can see everything at the same time. So let's just have that there and then move this down. See if we can do that a bit better. Oh, that's the minimum height of that ID, it seems. Okay, well we can just move it about physically then. So you can see we've got the Arduino Uno R4 Wi-Fi selected and connected as the main board, and we've got some code here. So we're going to be using the Arduino BLE library. So if you want to use this, you need to go to the tools, which is the toolbar at the top. Go to Manage Libraries, and you want to add in to this particular. I think it's Sketch and Include Library, and then just find the Arduino BLE library. If you've not got that there, you can go to Manage Libraries and find that, but I think on here, there it is, Arduino BLE. So you just need to do that. That'll make sure that this is downloaded and actually available for your code to run. I then define 3 different constants. So remote service UUID. This is the unique ID that we'll be using, the universally unique ID that we're using for our Bluetooth connection. Our Bluetooth then needs to have some kind of characteristic. So that's for the service. The characteristic is the button. So 2A6E is the button characteristic. And the device name that we're going to be searching for to connect to automatically will have the name Kev's Robots. And that's the name of the gamepad that we have. So my gamepad is just here. I can see it says connected on it as well. So I know that if I press up, down, left and right, my robot will respond to that. We've got this wait time. So this is a little loop that we have which will wait between the motors going on and off. So they've at least got some time to spin round because they are a physical thing. So we can change that. And when we press the button, how long, as soon as we let go of the button, how long do we want that action to carry on for? So this is like 1/4 of a second. We've then got some other variables, so BLE device, peripheral. That's going to allow us to communicate using the BLE of the Arduino. Connected is a true or false, so it's a boolean, so are we connected to the BLE or not? So that's going to hold that status. And then we've got some variables here for the motor, so these are all integers because they essentially represents the pin number for each of the motors. So motor A is going to be 12, motor B is going to be 13, and these numbers will change depending on what type of board you're using. So if you're using the Fujimoto, these are the correct GPIO numbers for each of the motors. There are different numbers depending on if you're using the official Arduino motor shield. So I think for this one it's either 10 or 3, GPIO 10 or GPIO 3, and then I think motor B is 11. I've got all that detailed on the smarsfan.com website, just out of interest. We've got our setup loop, so this one runs it runs once at the very beginning when we switch on power to our Arduino. So the serial.begin 9600, that's for our serial monitor down here, and we'll be able to print things out to the screen, a bit like we do with the MicroPython REPL. So this is going to print status things out and the like, just using this serial.print line. So while we don't have a serial monitor open, we can say while not serial, it's just going to wait there until that's then true. So once the serial is set up, it'll then work. So that's just waiting for the serial monitor to open. We then got this initialize BLE. So if not BLE begin, so if it hasn't begun, we can just say that the starting has failed, and then we can just say while 1, which is like while it's true. Just keep going around that until it does connect. So that logic is just a little loop to say beyond this point we should have a good solid connection to the Bluetooth BLE, and that'll keep trying until it actually makes a solid connection. So next up we have the main loop. So let's get to that. Oh sorry, no, we've got the last 2 bits. So pin mode motor A output, pin mode motor B output. This is just setting the type of digital pin that we're using. So these are going to be outputs. So we're going to be sending a 1 or a 0 or a value between 0 and 255 to each of these. And that can control the direction or the speed. We can then say BLE central started, scanning for Kev's robots, which is our Bluetooth remote. The main loop then is where we do most of the work. So this is going to be going all the time until we stop. So if it's not connected, we can say scan for name, device name, which is Kev's robot. So it's looking for that Bluetooth remote control, which we have as our gamepad. And that's running the exact same code that I created for the burger bot that we created way back when. So that's the cool thing about that. It works across different devices. So once it's found that, it'll then say BLE device, found device, BLE available. So we can then connect to that BLE device and get that to do various different things like just listen to commands, and then we can respond to those commands. So if it's found the device, you can say if found device local name equals device name. So it's found the Kev's robots gamepad. We can say found Kev's robots. We can stop scanning for it, and then we can say connect to peripheral, found device. So then our BLE device is then connected, and we can start listening to it and doing things with it. So we'll then poll it for notifications when it's connected. So if it's connected and the peripheral connected, we can say BLE poll. Otherwise, we can say if connected and not if connected is true and not connected, not peripheral connected, then we've disconnected from the Kev's robot gamepad. Connection equals false, and then we can say scanning again, so it'll automatically reconnect if there's any kind of problem with that. We've then got this connect peripheral, so this is just going to do the setup for the connecting to the BLE peripheral. You can see there, if peripheral.connect, then say connected successfully, otherwise we haven't connected successfully, and we can just return from that. If the peripheral discovered attributes, this is where the that special number that we had before we're looking for, so the service and also the characteristic, which is the button, that's what that's going to be listening for and trying to find that. And we can say get service or peripheral service, remote service, so this is trying to connect to the gamepad itself as a service. If it doesn't find it, we can print out some error messages there. If we have found it, then we can then search for the characteristic, which is the button. So there's a number of buttons on the gamepad, and each one can send a different command that we can listen to. And we can even have different command depending whether the button is pressed or released, so we can make our code really efficient with that. We can then subscribe to the button presses. So button characteristic can subscribe and button characteristic subscribe. So we can say subscriber to button characteristic notification, so it can listen to button presses in effect. Otherwise, we can just say fail to subscribe to notifications, and we can disconnect. Then we've got the next four things, which is the movement of the robot. So forward, we can use this to make our robot wheels go forward. So we'll print out to the monitor moving motors forward, just so that we know that that's happening. Then we'll do a digital write, so we're setting either a 1 or a 0. So if we set this low, that'll be a 0. If we set this high, then that's a 1. And because these motors are kind of pointing in opposite directions rather than being the same, we want them to run in opposite directions to make the robot go forward. And that might seem a bit confusing at first, but it's easier to play about with it. You can actually get around it by simply just wiring the wires the other way round on the motor shield board, or you can just fix everything in code. So on this one, we have motor A going backwards, motor B going forwards, and collectively, because they're facing opposite directions, that they will both roll in the same direction. We then do an analog write for the speed. So any value between 0 and 255 will give us a speed. So 128 would be half the speed. If you wanted to slow the robot down, 64 will be a quarter of the speed, and so on. We do that for both of the motors. We want them to both run at the same speed, so that the robot doesn't sort of pull to the left or to the right, that it goes forwards. So that's what that's for. And then we have that little delay because we want the motors to carry on for a certain amount of time, and that delay kind of helps with that. We've then got backwards, which is the same thing, but the low and the high are reversed for that. To turn the robot left, we have both of them low, and that'll make the wheel spin in different directions, and it'll make a bit like a tank, it'll turn. So if we get our little robot here, we want both these to go the same direction to make the robot go forwards, opposite direction to make them go back. And if we want to turn that way, then we need to sort of do that. So we need to spin, in this case, the left one backwards and the right one forwards, and that'll make it sort of turn on the spot. And it will literally turn at the centre of those two tracks, which is really neat. To make it go right, instead of it being built low, it'll be high. And then there's one for stop, which is essentially just set the speed to 0, because it doesn't matter what direction that we're travelling in, we just want the motors to stop where they are. Then we've got a little handler here for the button characteristics. So this is going to read in a little buffer. This is an unsigned 8-bit integer, because we just need a very low value for this. And we're going to read in the characteristic length. If the length is greater than 0, that means we've got some kind of command coming in there. And then we can print out what that command is. We'll just do print line command, whatever that command that we've read in from the Bluetooth radio. And then we can do this code could be quite a lot improved. We've essentially got a whole bunch of if statements. We could really improve this if we wanted to, but for simplicity, this just works. So if the command equals up down, which means if the up button is pressed down, then we can say up button pressed, and we can use the forward, which we created a second above the code there. If the up button is up, as in we've released it, maybe I should call it up pressed and up released rather than up and up down. That would probably make more sense. If the up button is released, then we want to stop the robot. If the down button is pressed, we want to make the robot if the down button is released, we want to stop the robot. If the down button is pressed down, then we want to make the robot go backwards. And similar for the left and the right as well. That's all the code that we need. It looks quite a lot there, but a lot of it is just the same kind of thing, just making the robot go backwards and forwards and so on. So we can actually now run this robot. What I will do, I'll just move this up a little bit so you can actually see the serial monitor. I'm going to hit the reset button on the robot, and we should see that we get some status commands there. So you can see it says BLE Central started, scanning for KES robots, found KES robots, connecting to KES robots, connected successfully, attributes discovered, subscribed to the attribute characteristics. So it's subscribed to the gamepad. Now if I hold up this gamepad and I hit the reset button, you can actually see on the gamepad as well. So if I hit reset, you'll see that this disconnects in a second. There we go, disconnected, and it's connected again, which we can see on the screen there. And if I press the up button, our robot rolls forward. If I press the down button, the robot goes backwards. If I press the left button, the wheels go in the opposite direction and the other opposite direction. And we can see each of those buttons being pressed and released in the status serial monitor down here as well, like so. Now what we can do if we want to actually test this out is we can disconnect this from there. We can put this on the desk, and it still says we're connected, which is good. And let's try moving this robot forwards. We can make it go left, spin on the spot, make it go forwards, make it go backwards, make it go right, forwards, left, forwards, and so on. You can see it's really quite robust. Play with this all day, it's so fun. You can also see on this motor shield, if I hold this up to the camera here, you can see that there's lights that appear that show you the direction of the motors. So if I press forwards, you'll see that there's an orange light and a green light on that left motor there. So both of them are going in the same direction. If I press backwards, both of the green ones. If I go left, we've got one green and one orange. If I go right, we've got one orange and one green. So that kind of visually shows you what's happening there. I've just got this little upturned chassis that I can sit it on, just so I can experiment while it's on the desk there. So if I just disconnect that for a second, you can see there it's gone connected again. I'll just do that a bit closer. If I hit reset, you'll see that it says disconnected and then it connects again. If I actually disconnect this entirely and then power it up again, we shall see that this fires up. So it says gamepad, it's connected, and that's how quickly it connects to the Bluetooth. It's very, very quick to reconnect. That's what I love about this this library that I've written. So that's how we can make this robot run. It's so much fun to do this. Cool. So we've gone through all the code there. If you want to look at how to build one of these gamepads, we've done a few shows on that already. How to design the PCB. I've got a whole bunch of these PCBs available. If I go to kesrobots.com, I'll just load up the website and we can have a look at this. I'll go to kesrobots. In fact, let's just put this on the other screen so that I can see it a bit easier myself. There we go. So at the top here we have PCBs. We can click on that and you'll see the gamepad is available there. And it's very simple to solder this up. It's quite a fun project. You can drop in the Pico on the back, put in the little tact switches, and you've got ones for menu, select and start. And if you put in the little OLED screen as well, which connects up to these 4 little through the hole connectors there. You can even have an entire user interface. We've even got some other buttons, A, B, X and Y there as well. There's a little connector there so you can actually put in a battery and power this, so the remote control is entirely wire free. We've also got the Servo Helper and the Pico Tamachibi virtual pet PCB. I'm not sure why that's not loaded up there, but yes, that's the circuit. And if you want to learn more about that, I think we'll go to projects. We can probably find the gamepad, which is there. So there's a couple of videos about how to design and fabricate the PCB itself, and the version 2 has some improvements over the very, very original version of this. So there you go, there's a little render of it. So the OLED display is one of the new features of the gamepad 2. 3 the holes for the Pico, so you just drop the Pico in the back of the PCB, and all the buttons are sort of wired to each of the different GPIO pins on the Pico. And we've got a little power input as well for the battery. Comes with loads of MicroPython libraries, so it's very, very easy to set this up. Now you can see all the different features of that there. So to buy this entirely would be like £18. So it's about £4.80 for the Raspberry Pi Pico WH or Pico 2WH with headers. You want 11 tactile switch buttons to put all on the gamepad, so you can actually click buttons. The little OLED display, they're only about £2, they're quite cheap. Get yourself a battery, they're about £5 for a 500 milliamp hour battery. You want a little JST connector so that you can actually plug in the battery to the connector there, and then we've also got the actual gamepad. It's only £6 for the gamepad PCB. There you go. I even created like a little virtual pet game that you can play just using the menu select and start buttons on there. And you simply just push these connectors through, solder them on the other side. Couldn't be easier. And then we just put the Pico on the back of the board and the OLED display on the front of the board. So very, very simple to do that. And there's all the how-to. There's the OLED pinouts to make sure you get the right connectors on there. So ground, voltage, clock and data. And there's all the GPIO pins and which button that they're actually connected to, in case you wanted to do something else with the PCB other than what the standard software library is providing there. So you can even draw text on the screen, completely customizable, absolutely loads of fun. There you go, there's the Pico Tamachibi one, which runs that same little game that you just saw just there. Cool, cool. So let's jump back to our slides. I didn't even say happy birthday to Arduino as well, so happy 20th birthday Arduino, and here's to the next 20. So if you want to get yourself one of these Robot Maker almanacs, these have all the pinouts that you might want to look up for the Arduino. So if I go to find the page for the Arduino, so there we go, the Uno is on page 10 and 11. So there's a little diagram there, and there's all the actual pins do on there, whether they're digital I/O or analog or pulse width modulation or 3 volts, 5 volts and so on. We even have one for the Arduino Nano, you can see there, and we also have the pinouts for the rangefinder as well. So everything that you possibly would need, it's in here. We've even got the physical dimensions of the Arduino Uno, and the Nano. Just trying to find where that is in the book. There we go. So pages 28 and 29. You can see the Arduino Nano and Arduino Uno pinouts there, and physical dimensions, so you can make your own robots and know that they're going to fit when you 3D print them. We also have the maker notes. This one has been heavily used. I put all my kind of sketches and things in here when I'm designing robots and whatnot. These come in packs of 3, so you can order them. And of course we have the gamepad itself. There's my gamepad that I've been using on today's show. So this one has got all the buttons put in. It's got the OLED display, and on the back there's the Raspberry Pi Pico, Pico W, and this is the header version. So you can just either connect in your USB connector there to program it, or you can apply some power on the board as well. So they're only £6, which is like ridiculously cheap. So head over to kevsrobots.com if you want to get yourselves a set of those. And if you've not joined our Discord community, then you're absolutely missing out. You definitely want to head over to kevsrobots.com/discord to join our growing community of people that are on there. And you can share all your robot pictures, your robot builds, and we can see what you're up to. Any kind of problems you're having, that's probably the best place to get the answers to them. And if you want to follow me on social media, I'm on all the different social medias. You can see on there, if you want to follow me on there, you'll get some all kinds of behind the scenes photographs, little heads up of things I'm working on. So one of the big projects I'm working on at the moment, I've got my printer, which is just behind me there. You can just see it printing away. It's currently printing out a Pi-Lomar, which is a Raspberry Pi based observatory for astronomy. So it's quite a big project, quite a big build. Some of the parts are absolutely enormous. I'm not sure I've got them to hand actually. No, they're right over there. I've got a lazy Susan for it to be able to rotate as well and follow stars as they track past. So pictures of that will be going up on social media very soon. So yeah, if you're going to follow me on there, definitely do that and say hi. And if you want to join me and support the work that I do, then you can do that in a number of different ways. The easiest way is to go to kevsrobots.com/coffee and you can buy a physical coffee. If you want to do that as a one-off, I'd be so thankful for that. If you want to join the membership program, you can either join the Buy Me a Coffee membership program, or you can join the YouTube membership program. Or if you're really generous, you can obviously join them both as well. So go over to kevsrobots.com/coffee and you'll find everything you need to know how to do that. So let's give a shout out to people who've done exactly that, shall we? So over here we have the coffees. Nobody's bought me a coffee in the past month. Clearly my videos have not been good enough or up to scratch, or people just haven't felt the need to do that. On the Buy Me a Coffee membership side, we've got Silicon Fiber, Marie TKD, we've got Andrew, Shemi, Jeff, DN Corty, Marlene and Tom. Thank you so much for supporting me on there. And then over here on the right hand side, we've got our YouTube members. So we've got Bert, Dale from Hybrid Robotics, we've got Marie, Michael, Steve, Ford, Bello, Oxrad39, Littleback, Paul, Johnny, Stephen, John Paul, Cassie, Tinkering Rocks, Johnny Bates, and of course we have Tom as well. So thank you so much for supporting. It means the world to me that you continue to do that. I can't thank you enough. And so at this point in the video, got the little spinny logo, so that's telling me that YouTube will be recommending over here one of the over 400 videos I've published to the website so far, to YouTube so far, and it's picked out one that it thinks you'll particularly like, so definitely check that out over here. And it's at this point in the video, if you're watching this on replay, I'll say thank you so much for watching, and I'll see you next time.